Now, let's talk about upper bounds. Picture this. An upper bound is like reaching for the stars. The highest limit that a quantity can possibly reach. It's the "what if it's at its absolute maximum" scenario. Now, let's flip the coin and talk about lower bounds. This is like digging deep. Finding the absolute minimum that a quantity could be. It's the "what if it's at its smallest" scenario. Let's start with the concept of an upper bound. An upper bound is like the maximum limit, or the highest possible value that a quantity or measurement could take. It represents the largest value that we can reasonably expect. For example, consider measuring the length of a desk. If we measure it using a ruler, the upper bound of the desk's length would be the highest measurement we can obtain, given the precision of our ruler. Now, let's move on to the lower bound. The lower bound is the opposite of the upper bound. It's the minimum limit or the smallest possible value that a quantity could take. It represents the smallest value that we can reasonably expect. Continuing with the desk example, if we measure its length using a ruler, the lower bound would be the smallest measurement we can obtain. Again, considering the precision of our ruler. Understanding both upper and lower bounds is crucial because it helps us convey the range of possible values for a measurement. It acknowledges the inherent uncertainty in our measurements and provides a more realistic picture of the quantity we are dealing with. Now, let's shift gears a bit. How do these concepts apply to perimeters and areas? Well, imagine we have a rectangle. The perimeter is the distance around the rectangle, and the area is the space it occupies. Let's explore how upper and lower bounds come into play when dealing with perimeters and areas. For the perimeter, think of it as the fence around your garden. The upper bound would be the longest possible fence you could need, and the lower bound would be the shortest. So, when we talk about the perimeter of a shape, we're considering the range of possible values that the boundary could take. If each of these lengths was measured to the nearest meter, what is the upper bound of the perimeter? The lengths measured to 12 meters have a minimum length of 11.5 meters and a maximum of 12.5 meters. The width of 15 meters have a minimum length of 14.5 meters and a maximum of 15.5 meters. The maximum perimeter would be found by adding all the upper bounds. So 12.5 plus 12.5 plus 15.5 plus 15.5 is equal to 56 meters. If we wanted to find the lower limit of this perimeter, we would add the 4 lower bounds to get 54 meters. A difference of 2 meters. Now, let's talk about the area. Picture it as the carpet covering the floor of your room. The upper bound is the largest possible carpet you might need, and the lower bound is the smallest. When we discuss the area of a shape, we're looking at the potential range of space that the shape could fill. Now, let's go back to our previous example to find the upper bound of the area. We need to multiply the largest of our bounds together to find out the maximum area we might cover. So, 12.5 times 15.5 equals 193.75 meters squared. For our lower bound area, we use the lower bounds. 11.5 times 14.5 is equal to 166.75 meters squared, which is 27 square meters difference in the two limits of our areas. This is quite a large difference,